So in this video presentation we're going to look at the connections for converting a one-way lighting circuit. So in other words, you walk into a room, let's say a ceiling rose and pendant or batten lamp holder, and there is one switch that will turn on and off that light. We're going to look how we can convert that to have control via two positions by converting it to two-way switching. We can see the current switch drop down from the ceiling rose is in blue, brown and green and yellow. So we've got twin and CPC cable. We remember from a previous presentation that the blue is not a neutral and is a switching line conductor and is identified with brown sleeving at both ends. And we bring down a permanent line connection on the brown conductor, which is connected in common. On operating the switch, it puts a switching line conductor through to L1 and will turn on the lamp in the room. Remember that the switch drop could be in twin brown, therefore both conductors are identified already and no sleeving is required. Or in old colours we could be in red and black, with the black one identified with red sleeving, or it could be in twin red. The cable that does come down to the switch drop, whichever of the four described it is, in this case it's twin and CPC, remains in place. However, the switch, which is a one-way switch, will need to be removed. We will also need to add a cable in from this switching point to the new switching point in the room, and we will need to put two-way switches in both locations. So this will have a two-way switch replacing the one-way at the original position, and the new position within the room will also have a two-way switch. Let's see what that looks like while we add the cable in, and obviously we replace this switch and add a new switch in. The switch shown at the top of this presentation is the one that we originally showed in the first part of the presentation, and still has the cable being a twin and CPC coming into it. The new cable that's been introduced to link together the two switch positions is a 3-core and CPC. We said in the first part of the presentation, when adding an additional switching point, we would have to change the switch from a one-way switch to a two-way switch. We can see that both switches are two-way switches, comprising of common, L1 and L2. So let's have a look at the terminations that are going to be made in our original switch position at the top now, but with a two-way switch. My original twin and CPC cable now is connected brown conductor in L1 and my blue conductor with brown sleeve in L2. It wouldn't matter if they were the other way around, but that's what is shown in the drawing. We've introduced the 3-core and CPC to link together this two-way switch with the new two-way switch position. The terminations, as I would do at college, use black for common, identified also with brown sleeving because it's a switching line conductor. My brown goes in L1 and my grey conductor of the 3-core goes in L2. When we look at the bottom switch position, as long as we have the correct cable in common, and I've used black for common and it's shown in the common position with brown sleeving, it wouldn't matter if I have the brown conductor going in L2 or L1 and the grey conductor going L1 or L2. It makes no difference in this switching configuration. However, you can see in the drawing I've kept it exactly the same, using brown in L1 and a grey conductor identified with brown sleeving in L2. I've now got control from two different positions from my original lighting point. So I've added another switch. In order to add another switch, I've added a 3-core and CPC cable from my original switch position to my new switch position. I've replaced the front, which was originally a one-way switch, with a two-way switch, and the second switch also has a two-way switch at its position. So with this new configuration, I have control over my lighting point from now two positions. I can turn it on and off from two different positions within the same room. In the final part of this presentation, we're going to look how we could introduce a third switch, making the switching arrangement two-way and intermediate. So let's look at two-way and intermediate switching. For all intents and purposes, it looks as if we've just added a switch in the centre here. However, if we had two-way switching, as we did in our previous drawing that I discussed, it would actually be the bottom switch that we've now added in. We've extended it to be 3 switches. If we look at the top switch, it's still fed with a twin and CPC cable and still has a 3-core and CPC going on to the next switch position and still is a two-way switch. The 3-core feeds into our second switch position as it did before, but we've added another 3-core cable from that position down to what would be our new switch position at the bottom. And we've had to replace the center switch from a 2-way switch in our previous 2-way drawings now to be an intermediate switch. The 2-way switch appears at the end, so at the bottom switch now, which is fed from a 3-core from the switch above, is a 2-way switch. So in real terms, from the drawing we just looked at, the 2-way switch has moved down a position to be in the bottom. In order to have 2-way and intermediate switching, the first switch is a 2-way switch. You can have as many intermediate switches as you like. I've only shown one in this drawing. And then followed by a final 2-way switch. So we could have shown 20 intermediate switches as long as the first switch was a 2-way and the last switch was a 2-way. Let's have a look at the connections in each of the switches now. So let's have a look at the connections in the top switch, which are identical to the ones shown in the previous drawing for 2-way and intermediate. We're using black as common, and then we've got brown and brown in L1, one from the twin and CPC and one from the 3-core, and we've got a blue with a brown sleeving and a grey with a brown sleeving coming out the other connection within the 2-way switch. The intermediate switch, the one in the middle now, has a slightly different configuration. The switch itself has 4 termination points, and the general rule with intermediate switches is a set from a 3-core will go in the top and a set from the 3-core will go into the bottom. It wouldn't matter which way around they go as long as a set goes in the top and a set in the bottom. Occasionally manufacturers do them across the side. All the ones I use in my workshop will have a set coming in the top and a set going out the bottom. So from the 3-core we can see we have a brown and grey from one of the 3-core and CPCs going into the top, and the grey again is identified with brown sleeving, and in the bottom from the other 3-core we use the brown and grey with the brown sleeving identified again. These brown and grey conductors connected in the intermediate switch are called strappers. The common is not physically connected into a termination within the switch itself. It is actually joined together. In other words, the black common from the top switch and the black common from the bottom switch are connected together and left in the back of the box of the intermediate switch. I've shown a red through crimp for the connection here, but it also could have been a maintenance-free connector to join those two conductors together. And the 3-core coming out the intermediate switch down to the final 2-way switch has the standard configuration for connecting. In our case we're using black as common, and we've got brown and grey with brown sleeving connected in L1 and L2. Remembering again, it wouldn't have mattered if brown was in L2 and grey was in L1. The drawing shows them the other way round. So this would give us 2-way and intermediate switching of a lighting point. So in other words, there is 3 positions in which we can turn the light on and off from. However, as stated previously, you could have had as many intermediate switches connected as shown here in this circuit as you'd like to have vastly greater control over the light. So we could have had 10 switches controlling the one light. I hope this has been some help.